Okay, let's unpack this. For centuries, really, we've looked up at Mars and wondered, is anyone or anything out there, or was there ever? Today, we're diving deep into something pretty exciting from NASA's Perseverance rover. It seems to have found a potential biosignature.
That's right. In a sample they're calling Sapphire Canyon.
Right, from an old riverbed in Jezero Crater. Now, potential biosignature, that means it might be from life, but we need more proof. Yeah.
Exactly. It's a clue, a substance or structure that could have biological roots, but it needs serious investigation. Still, this is big. What's really fascinating here is, well, many are saying this is the closest we've ever come to actually finding signs of ancient microbial life on Mars.
Wow, yeah.
Yeah, even the acting NASA Administrator Sean Duffy called it a groundbreaking discovery. He stressed NASA's commitment to what they call gold standard science.
Gold standard science. Makes sense. So for you listening, this deep dive is basically your shortcut to understanding the science, the evidence, and, well, the huge questions this raises. So where exactly did Percy find this? Let's picture the scene.
Okay, so the rover was exploring a spot called the Bright Angel Formation. Think rocky outcrops on the edge of Neretva Vallis. That's the ancient river valley, right? Yeah. Carved by water flowing into Jezero Crater. Precisely. A really significant location, geologically speaking.
Right.
And back in July 2024, the rover stumbled upon this specific rock, about 3 feet by 2 feet, named Cheyava Falls.
Cheyava Falls. And that's where Sapphire Canyon comes from.
That's the one.
Yeah.
And the geology there is, well, it's key.
How so?
The rocks in Bright Angel are sedimentary. They're made of clay and silt, and on Earth, those materials are fantastic at preserving signs of ancient microbes, like little time capsules.
Okay. Good preservation potential. What else?
They're also packed with interesting chemistry. Organic carbon, sulfur, oxidized iron, basically rust and phosphorus. The lead author on the study, Joel Hurowitz, pointed out that this specific mix, well, it could have been a really rich energy source for microbes back then. Food, essentially.
The perfect cocktail for ancient life. So environment, check. Materials, check. Then what? How did they spot this biosignature?
Well, Perseverance has these amazing instruments, PIXL and Sherlock. They analyze rock chemistry up close, and they started seeing these colorful spots on the Cheyava Falls rock.
Colorful spots? Sounds intriguing.
It definitely got the science team's attention, so they looked closer, higher resolution. And these weren't just random spots, they formed a distinct pattern.
A pattern?
Yeah, minerals arranged in what scientists call reaction fronts. And the key finding was the signature of 2 specific iron-rich minerals, vivianite and gatching.
Vivianite and gurgite. Okay. Why are those 2 special?
Well, on Earth, vivianite often shows up in sediments near decaying organic stuff, peat bogs, places like that. And gurgite, some microbes here actually make it as part of their metabolism.
Ah, okay. So finding them together in a pattern.
Exactly. It's the combination and the arrangement. It looks like they formed through electron transfer reactions. Think sediment reacting with organic matter.
Like a tiny natural battery.
Sort of, yeah. Microbes on Earth use these kinds of reactions to get energy. So finding a geological fingerprint of that process on Mars, that's potentially a sign of life using a known energy pathway. It's very suggestive.
Suggestive, okay.
Yeah.
But the big question always is,
yeah,
could it be something else? Can we be sure it's life?
And that's the critical point, always. These minerals can form without life abiotically. Things like high heat or really acidic conditions could maybe do it.
But
the rocks at Bright Angel don't show any signs of having gone through that kind of extreme processing. No evidence of high temperatures or strong acids.
So that makes the non-biological explanation less likely.
Less likely, yes, but you can't completely rule it out yet. As the Perseverance Project scientist Katie Stack Morgan always emphasizes, astrobiological claims require extraordinary evidence.
Extraordinary evidence, right.
Yeah.
They're not jumping to conclusions.
Absolutely not. They use frameworks like the cold scale confidence of life detection, which has 7 levels, basically benchmarks, to assess the evidence really rigorously. This finding is being put through its paces.
Good to know. Okay, something else that struck me was that this was found in younger rocks. That seems odd.
It is a bit counterintuitive, isn't it? It was found in some of the youngest sedimentary rocks Percy has looked at.
What does that imply?
Well, it might mean Mars could have been habitable for longer than we generally thought, or maybe habitable again later in its history.
Wow.
Yeah, it opens up new possibilities. Maybe we should be looking more closely at younger rocks too, not just the really ancient stuff. It kind of broadens the search.
So to sum up, Sapphire Canyon, taken from the Cheyava Falls rock, is a really significant potential biosignature. One of, what, 27 samples collected so far?
That's right, 27 cores waiting for a potential ride back to Earth for much deeper analysis in labs here. And if you think about the bigger picture, the idea that Mars might have had life-sustaining conditions for longer, maybe later, that really changes how we think about habitability, doesn't it?
Not just for Mars.
Exactly. For other planets, too. It just makes you wonder, If Mars has been hiding these subtle leopard spots right next door, what other secrets are out there? What else might we find if we just keep looking, keep developing the tools to see?
A profound thought. It's definitely a story we'll keep following. What stands out most to you from this deep dive? Something to ponder.